universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Well, hey, good evening and welcome to Sky Tour Radio here on KGRA and KGRA DB. It is I, Mark D'Antonio, and we have with us, as always, we have Daryl down there. We have Amanda right here, and over there in the corner, we have Tara. Tara is, of course, one of our newest additions to the show, as you know, and she has her wonderful Tara's Cosmos that she goes through. And Daryl is doing his wonderful Stellarium runs each week. We do a deep dive with Daryl, and he's got some really cool things planned for you tonight. So that's going to be a lot of fun. So what is Sky Tour Radio? Well, Sky Tour Radio is kind of an extension of Sky Tour Livestream, which is our YouTube-based live deep sky observatories that we have. And that's plural. We have 2 now. And these observatories bring you the beautiful night sky. You see the birthplaces of the stars. You see the places that they blew up, where they died, basically, and ended their existence. You see these glittering jewel boxes in the night sky, brilliant clusters. And these are brought to you courtesy of our research quality telescopes. And we set out on this journey a number of years ago, and we decided that it was going to be really important to do outreach. You know, most of you and practically all of you know that I'm actually an astronomer. This is what we look like, right? And so astronomy has always been one of those sciences that I just couldn't get away from. When I was 9, I looked up in the sky, and everybody here knows this with me, and I just felt homesick. I felt like I belong there. I belong learning about this. I want to learn more about it. And that led to my interest in unidentified flying objects, of course, and in astronomy. And so becoming an astronomer was a huge achievement. And when I graduated with my astronomy degree, I couldn't have been more proud. And then I realized there is so little that we actually know about the universe. And that's why I said, you know what? As an astronomer, if we know so little about the universe, then how about the people out there that listen to the science folks? They probably know even less. So I embarked on a different career. I decided to take my astronomy and go in public with it and basically go into the outreach sector. And that's what this is all about. That's why Sky Tour Radio. That's why Sky Tour Livestream. Sky Tour Radio, however, if you want to blame someone for it, you have to blame our esteemed producer, Bill. Bill, New York Skywatcher, is our producer, and he is at fault for Sky Tour Radio. So if you like it, it's his fault. I think that's kind of a compliment, Bill, when you finally listen to this. So that said, I want to welcome all of you to the show tonight. And I want to say, hi, Daryl. How are you? Okay. And say
I'm fine, Mark. Thank you.
And Amanda. Hi, Amanda. How are you?
I'm well. How are you?
I'm
Go
doing
Team Canada.
well. Okay. We do have the Olympics and that are in progress. And you know what? I'm sorry, but until someone told me about 3 hours ago that there were Olympics going on, I had no idea. So,
well, isn't there a ring nebula? That should have been a tip off.
there is a ring nebula, in fact, and we're going to be seeing it in a little while, actually, too. But yes, and but that tells me about that's a planetary nebula, and I think about older stars that are aged, that are sloughing off their outer layers as they start to change their sizes. They pulsate and they push off outer layers. Well, that's kind of what happened with the ring nebula. But it doesn't remind me of the Olympics.
We need 4 more.
That's true. We do need more to match the Olympic rings. Now, the question for you, Amanda, is how is Canada doing?
2 silvers so far. Only officially entering day 3 now. So Tokyo is conveniently 12 hours ahead of me. So I start my Olympic day at 7 at night until about 9 the next morning.
Okay. All right. Well, you said silver medals, right?
2 silver so far. We're getting there. We're working on it.
Yeah. Do you know the periodic table symbol for silver?
I did.
Do you know where silver comes from in the universe?
Oh my god.
I know you don't.
This is what I get for derailing the show right off the bat, right? Silver,
No,
I would say an asteroid, maybe. They usually
actually,
bring chemicals and elements to our planet, don't
you're
they?
exactly
Elsewhere.
correct. That happens. That's correct. But really, some of the heavier elements were born when neutron stars collided, and when other heavy, more massive stars went into collision. I mean, and that seems to be the source of most of the gold in the universe.
I was gonna say, didn't we see that a year or two ago? And they said this kind of confirms our theory that maybe this is where gold comes from. I know Ronald's in the chat, so his ears just perked up. But
Well, yes.
yeah, I was thinking that
gold
too, because
prospector.
gold was there, maybe some kind of explosion or collision.
That's right.
It's crazy, right?
Yeah, and it's really important because when you talk about the most abundant elements in the universe, and we're going to get to that too because that's one of Tara's questions tonight that she'll ask, and I have a bunch of things we can say about that. But yeah, I mean, you think about the abundances of the elements in the universe, and obviously, what might you suspect? I mean, considering what stars are made of, and this is a question for Tara, for Daryl, for the people in the chat. Daryl knows the answer to this, so maybe Daryl, you should not say anything. I know you know. But for you too, Amanda, I mean, the question is, what is the most abundant element in the universe? Okay, what do you think it might be? And I'll start with you, Amanda.
I think I might know. I have a feeling Tara's gonna know too. So let me take my piddly guess right now. Is it carbon?
Not quite, but very good guess. Tara?
I was going to say maybe hydrogen.
Tara's correct.
I knew she'd know. I knew she'd know.
Yeah. If we think about a million atoms, a collection of say a million atoms. Okay, how many hydrogen atoms would be in that typical million atom collection? And the answer is over 700,000. Okay, wow. And helium is just over 200,000. So it's next, right? And carbon is down the list. And we're going to talk about that. That's actually very important because carbon is the reason why we would have, for instance, planets like this. Okay, this is our world, right? And so having planets like this is exactly because of the carbon that's in the universe and all the other elements that end up, making it into our planetary composition. And that planetary composition has been due to things like, as you said before, Amanda, asteroid strikes, okay, meteor strikes, and also due to things like cometary strikes, because that's happened too, So, we have a beautiful world, and this world is floating. It's as Carl Sagan said, it's a pale blue dot, and it really is. It really is. And for those wondering what's going on here, this is going to be one of our journey machines tonight. We actually talked about the universe being like a time machine. And so this is the real universe that we're looking at out here. You can see the Pleiades is right here. Here's the Hyades with Aldebaran. And then as we move over, you'll see Orion. Okay, so here's Orion right here. Okay, I'll show you that. Here's the belt of 3 stars. Here's Betelgeuse up here that was dimming madly last couple of years ago, and we have the Orion Nebula down here. There's a lot going on, So we'll be taking a look at this in a little while, but I just wanted to make it clear that our planet has been founded on the element carbon and the other elements that have made it here. But you would say, well, then if hydrogen's so plentiful, why isn't it all over our planet? And it isn't, right? In fact, hydrogen and helium are kind of in short supply. Well, they're very light, and they also bond with all kinds of things. Okay, like an acid is carbon, two oxygens, and a hydrogen. Okay, you have these what are called hydroxy radicals. Okay, you have an OH group, and that's oxygen and a hydrogen, and you have all these other compounds that have a hydrogen in them. Yes, you can liberate the hydrogen, and some ways that might make it easier for us to get the chemicals we may need to do certain things, but it doesn't take away from the fact that we actually have a finite supply of this material. And it all comes down to the fact that the universe has provided us with X amount of stuff. And that X amount of stuff isn't necessarily permanent, right? We find that out by when we look at the complex hydrocarbons and that we call oil in our underground reservoirs, basically. And we know it's finite. Oil was made by the compression of the dead bodies of many, many, many creatures over millions of years. And as a rock strata, piled up on them, the pressure was effectively squeezing out small pieces, small elements of oil from their bodies, and it ended up seeping into these large reservoirs, right? Coal comes from, and coal is carbon. Coal comes from the compressed trees that ended up underneath lots of sediments over the millions of years. It's really an amazing evolution that's occurred on this world, and so when we look at this, we think about it, and we think about how much our world has evolved. But we also look at the fact that we have this moon that's around us, and our moon, I grant you, is a little odd because it's a fairly large singular moon. Most of the other planets that have moons have more than one. Mars has two tiny ones, Phobos and Deimos, right? Neptune has a whole bunch of them, and Jupiter and Saturn have a lot more, and even Pluto has a moon, a singular moon, Charon, but they're tidally locked to each other. They go around each other in the same way, which is really cool. And the moon's tidally locked to us too.
They have discovered additional moons around Pluto, have they not?
I didn't want to say anything about that because I wasn't sure if that was confirmed yet. But I think that there are. I saw, and what Daryl's referring to is there was another discussion whether Pluto actually had more than just. Oh no, I'm sorry. You know what? I totally apologize. Daryl's completely correct. Yes, Pluto has a lot more moons. It has like 6 moons, and I can't believe my brain was baked on that. I apologize. Thank you for that, Daryl.
Do I get a Scooby snack?
You get a Scooby snack, absolutely. And here's a drink of water for you.
Is that going to affect its planetary status or lack thereof?
Pluto has always been a planet to me. I'm sorry.
Me too.
You guys know the story. I met Clyde Tombaugh, the guy who found Pluto. He was a little old man when I met him. Very, very short. Very, very nice guy. No ego whatsoever. I mean, that's, guys like that influenced me, in terms of, how you carry on. If you're like one of the biggest discoverers of something, how that won't go to your head was exemplified by Clyde Tombaugh. Okay. Carl Sagan had multiple degrees in astrophysics and other astronomy. Okay. And it didn't go to his head either. Yes, he was a public figure. He was a spokesperson. He came out and was more like a teacher of astronomy, which is where I go. That's where I go. So, with Clyde's humble nature and Sagan's exemplary teaching style, it's to me, that's a win-win. And I think that's the kind of thing that reaches people, right? And people don't understand science, but science is something that is for everyone. And that's why Daryl down there, that's why Tara over there, that's why Amanda right here. Okay, bringing you science in terms that is digestible by everyone, right? We can talk over everyone's head if we want to, but what for? What's that do? How does that serve? How does that make you want to do some astronomy? How does that make you want to, come look at our live observatory at night and hang out with us? We're not getting any money for that. We're not doing it for egos. We're doing it because we want to see people learn, So That's what it's all about. And I think that, when we look at how we evolved here on Earth, every discovery we've made out in the universe with the Kepler Space Telescope, with TESS, the Transiting Exoplanet Survey Satellite, and with the upcoming JWST, James Webb Space Telescope, okay, when that's up and running, and we have a little update on that in a moment, then we're going to see a lot more. As it is, we're seeing more now. We're actually able to penetrate some of the veils that have been hidden from us. Remember, it's been hard enough to find planets around other stars. But how about moons around planets that are around other stars? That's something that just happened. We're getting to the point where we're able to actually find moons around other stars, around other planets, around other stars. So here's the system we're talking about. This is PDS 70. And PDS 70, the star is in the center. The reason you can't see it is because the star has been digitally removed, okay, to remove its glare. And we're looking at it from the Atacama Large and Submillimeter Array down in Chile. And this particular view is showing us a circumstellar ring of dust, which is that large disk you see. Think of that as an asteroid belt around the star. And then you see that bright dot. Okay, that bright dot is one of two planets that have been caught here. Okay, and the first one is PDS 70b, and this here that we're seeing is PDS 70c. Okay, little c, little b, right? And that dot, though, is actually a planet in formation. It's actually a 4 Jupiter mass planet that's forming there. It's not quite finished. But if you zoom in on it, look at that. It has some stuff around it. Now, this array down in Chile is very sensitive and isn't showing garbage data here. It's actually showing you dust, mottled and complex with dots that are around this forming planet. What is that? Well, let's go back to the star for a second. The star is a star that, if you would call it a star that was on our main sequence, like a normal hydrogen fusing star, it would be like a K7. Or if you recall, we have our stellar classification scheme right here. Okay, Amanda knows this well, and I'm sure she could recite it for us and tell us what it is. Amanda, you're up, and I know I didn't tell you that you were doing it.
What? You're telling me to recite it, but I see the letters right in front of me. Are you looking for a description or the mnemonic?
Exactly.
Or
describe what you know about it, and then mnemonic. Sure.
At the bottom, you see the letters that correspond in color with the circles above. Those are different kinds of stars and whatnot. O, B, A, F, G, K, M. You can remember that by O, be a fine guy, kiss me, or O, be a fine girl, kiss me, depending on your preference. And the O's are the bigger, bluer, hotter. And then they go smaller, kind of white, yellow, and then all the way down to red. And they're smaller and cooler, but they're still stars. So they're still quite big and hot. But the smaller ones are red. And think of a flame, like if you're lighting a lighter. The really hot blue stuff is at the bottom, and as it cools, that's when you see the orange, right? So
exactly right.
Yeah.
Thank you, Amanda. That was done with impeccable accuracy. Very well done. And this star we're talking about, PDS 70, and that's Peter Delta Sierra, PDS. Okay. It's actually, if it was going to be called a main sequence star, a star that is now doing, say, fusing hydrogen into helium, it would be a late K star, K7. Okay, so it'd be smaller and last longer than our star, because the age of the stars also increases as you move to the right on that stringy line called the main sequence. Right. However, the problem with PDS, the PDS star here, PDS 70, the problem with it is that this star, this planet rather, the star, PDS 70, isn't quite on the main sequence yet. It's actually what's called a T-Tauri star. It's a variable, and it's called a pre-main sequence star. So it's sort of nursery school before kindergarten for stars. Okay, the temperature's almost there, the processes are almost there, but there's still some factors that define it as not being quite on that main sequence where normal stars reside. And so
Well, Charles has a question. I'm wondering if that's going to tie into this. He wants to know what the star's age is and if it's still forming, but it sounds like it is. Is there an age range for kindergarten in star nurseries?
it depends on their mass, but this particular star at a K7 is only about 12 million years old. And so it's literally a youngster, a child, not even a toddler on the stellar scale. It's an infant, maybe nursery school age. It's about to hit the main sequence. When it gets to the main sequence, then it'll be considered a stellar toddler. But at K7, it's going to go for many, many, many billions of years, longer than our sun by far. Because as they get cooler and smaller, basically, and lower temperature, basically, they end up having much longer lives. And this will be, it'll come onto the main sequence as a K7 is what we're thinking here. So now, it's a variable star. You're welcome, Charles. It's a variable star, again, known as a T-Tauri for the first one ever found in this class. They're pre-main sequence stars that are very, very variable in their brightness. And that variability can cause problems. But as you can see in this system, this system is pretty cool. It's showing us that even with this T-Tauri star, we have a circumstellar disk, all right, of dust, like asteroid belt, basically. And we have a circumplanetary disk, like this right here in the middle, around the forming planet. That's about 4 times the mass of Jupiter. So basically, at some point in the future, this planet is going to have a whole bunch of moons, just like our planet Jupiter does, but 4 times the mass of Jupiter. Now, 4 times the mass doesn't mean 4 times the size. Okay? A planet that has a radius that's twice the size of Jupiter isn't twice as massive necessarily. It's probably going to potentially have a lower density overall and be kind of not as massive. I mean, it's possible. But it could also be 10 times as massive, okay, almost, as Jupiter, okay? And stars typically have 80 times the mass of Jupiter, okay? Now, people say, well, that means if you give Jupiter 80 times the mass it has now, if we could just feed mass into it, does that mean that we're going to end up being able to have a star? And the answer is, well, maybe, okay, as long as you're feeding it the right kind of mass. But we even found a star that's smaller in diameter than Jupiter, but it's a star because it's a compact body that actually has more than 80 times the mass of Jupiter, and it's a star. Okay, so the universe is throwing things at us that make it really, really interesting to study this stuff. It's just getting worse by day. It's like, I'm so confused. But don't worry, you stick with us, and we'll make it. We'll help you figure it out. So PDS 70, yeah, Daryl.
I'm sorry. When PDS 70 gets its star merit badge, is it still going to be a K star, or will it go bigger or smaller?
Good question. When it gets onto the main sequence, it's just pre-main sequence now. It's almost there. When it reaches the main sequence, it's actually going to appear on the curve, the main sequence curve, at about K7. That's where it's suspected to land. And for those that want to know more, it's on something called the Hayashi track. Okay, Hayashi, Hayashi track. And we know how the Hayashi track works with pre-main sequence stars, and we can see where the Hayashi track leads for different masses and different stuff, and you can figure out what it's going to be. So they're looking at it as like a K7 when it arrives on the main sequence. So it's the Hayashi track that is telling us all this. Now, this star is only like 370 light years away. I might have said 400, but I was rounding up. But, it's really cool to see this happen. It's really significant, all right? And there are 2 planets, but you can't see them because the other one is out of the shot here. You don't see it, okay? But it's kind of interesting to see a extraterrestrial asteroid belt potentially. This is a circumstellar dust ring. Well, from another world, our asteroid belt looks like a circumstellar ring, and the Kuiper belt looks like a circumstellar ring around our sun, and the Oort cloud that is that spherical halo of cometary icy bodies that are all around the sun will look like a circumstellar cloud. All right, so we actually look the same way to somebody else. Okay, that we as we see with PDS 70 in a sense.
Hey,
So it's
Mark.
kind of cool.
Hey, Mark, does
Yeah,
ours glow like that? Do our rings glow?
Okay, let me explain that. That's a very good question. And thank you for pointing that out, Tara. When we look at this glow is based on the fact that the telescope that gathered the imagery was just looking at a particular wavelength of light, and it exposed it. It took the was probably called integrations of light coming from this object. It's not glowing per se in the same way that our nebula here, isn't glowing because of the fact that it's got this bright blue light in it. Okay, it is glowing. Okay, and this is also glowing, but it's glowing in a different light. But if you take enough of that light in, it looks like it's very bright. Okay, the star in the middle was removed digitally, so that little hazy thing in the center is just the place where they removed the star digitally. All right. And they actually prettied up the image so that it doesn't look like it has a black circle in there, on a culting disk that takes it out. But the glow is just a artifact of how long they integrated or brought this image in time.
Is it fair to say that's not really a direct image then?
Well, it's a direct image for the submillimeter array in the Atacama telescope.
So you're talking more like radio wavelengths?
Yeah, it's definitely going to be out in the radio wavelengths and so forth. And it might. I'd have to see if the Atacama array can also. I think it may border in microwaves, and I don't think infrared is part of its makeup. But the James Webb Space Telescope, if it looks at this location, will be able to gain a lot more information than probably that array. And that'll be interesting. And speaking of James Webb, actually, I'd like to give an update. It looks like the James Webb Telescope is done in terms of preliminary testing and getting it all ready to go. It's been a long time coming. And if you can believe their time schedule, which has changed and slipped over time, right? It's going to get shipped to the Cape in August sometime. And then that means they do what's called the launch preparation phase, where they're going to button it up, get it in its launch vehicle, get it positioned and all buttoned up in there and ready for launch. And that's a 2-month process. So the soonest we can launch is around Halloween in this coming Halloween.
Did you see Dan's question in chat? Sorry if I missed it.
No.
He was asking, with the image we were just looking at, he wanted to know, would the web scope be able to resolve it? Since you're speaking, I just thought maybe you saw his message and that's what prompted your update.
Yeah, Dan Delaire, good guy. I actually know him.
Hi, Dan.
Yeah, well, I'll say hi to Dan. Hi, Dan. The James Webb Telescope is going to have a resolution that's much higher than the Hubble Space Telescope, obviously, but it looks in the infrared. So we're going to be able to check out this object with a different set of eyes. As far as the resolution, I don't know, but we're going to be looking at infrared imagery. We're not going to be looking at radio imagery, which is generally lower resolution. So we're going to be looking at something that's a little higher resolution, I think, than this. And that's what's going to be very exciting. That's going to be very exciting here.
I think I've seen it said that, at least hopefully, that the web will be able to directly resolve and image such objects, correct?
I hope so. I mean, but they are very distant and very small. So and so far, without using a special technique called interferometry, we can't resolve the disk of a star, other than like using this technique. And for those, we have like done stars like Antares, Betelgeuse, VY Scuti, these big, 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 big stars that are so big that if you put them where the sun is, they would go all the way into the outer solar system in size. And this interferometric way of getting the image of a star is what we can do here on the Earth. But James Webb is still going to be, I think, too small to resolve actual disks of exoplanets. I don't think it's going to be able to see that. What it can see is the atmospheres of the exoplanets and how they pollute the star's spectrum. That's what's cool. As a planet first goes onto the stars, it first crosses the star, right at that point, we're just going on the star here. Okay. There's going to be a piece of the atmosphere of that planet that is going to be now interfering with the star's spectrum. When that happens, we're going to see that in the star's spectrum back here. And it's going to look like something new in the spectrum. And that is going to tell us the composition of the atmosphere, if it exists at all, of this planet that's passing in front of it. And that's the kind of thing that we're banking on. Although you got to keep in mind that we can't do that if the planet's doing this. If it's going around the star in a way that isn't edge on to us, where we can see it going around the star this way, then we can't see the planet at all. Then we only have the wobble of the star being tugged on by this planet, possibly, as it goes around. And that's called astrometry, and that's usually quite poor, But those are good questions, and thanks. So that's PDS 70, folks, and that's the first actual evidence of a set of moons forming around an exoplanet. That's pretty cool.
And with that picture, I'm not sure again if this was touched on or not. Daniel wanted to know, was it an X-ray or radio? The imagery.
It wasn't X-ray. This was actually out in the millimeter wavelength. So we're talking about something way out past the visible end of the red spectrum and beyond. Okay, so we're looking at a longer wavelength. Okay, X-rays are very short wavelengths. These are long wavelength images.
Okay. I figured it wasn't either of the two, but I wasn't sure how it was measured. So
I next time I'll ask you, because I think you do know the answers. You know more than you think.
You're a funny guy.
You've demonstrated that.
Okay.
And everybody here and everybody in the chat and everybody listening and watching knows that of you.
Oh,
You're
thank
amazing.
you, everybody.
One way. Yes, you have.
Thank you.
I agree.
Oh,
See?
thank you.
See, now you've had it. Now that's it. The definitive answer. Tara agrees. It's true.
My ego's been nice and plumpant. I can go now.
Plumping. Is that a word? Plumping?
I don't know.
I like it. Okay. Well, I also wanted to hit something too that Daryl sent me this story earlier in the week, and you remember the Mars Insight lander mission. It was a lander that landed on Mars. It doesn't rove around; it just sits there, and it has instrumentation. And the idea was to get a look at the Martian interior, and I believe it actually had a microphone. I think the first wind we heard was from the Insight mission, if I don't miss my guess. But the Insight mission has been listening to Mars quakes since 2019, actually. And we know a great deal now about the interior of Mars. And, you think about the Earth, okay? And we think about how the Earth was formed, what it's made of, and its layers and all that. And the interesting information coming into us from Mars from this Insight lander is that, we know, as expected, Mars 2 was once completely molten like the Earth. Okay. And Earth has a crust, a mantle, an outer core, and an inner core. Those are the various zones below the surface, right? And we assumed for the longest time that Mars had the same, Well, it turns out that Mars, even though it formed pretty much the same way as Earth, it differentiated, or the interior was made different by the way it cooled, and by its evolution and what happened to it over time, and of course by its size. And so Mars doesn't have this what we call a variegated core, where it has a outer core and an inner core. The inner core of the Earth is solid. The outer core is molten. Okay. And Mars doesn't have that. Mars just has a core. It has a crust. It has some form of mantle, and it has a core. Now, that's pretty interesting. And it's different from the way the Earth formed, right? And it's interesting too because we know that at one time Mars had a lot denser atmosphere. We know it had a lot more carbon dioxide, oxygen in its atmosphere, plus other elements, and that they got whittled away by the copious rays, the ultraviolet rays coming from the sun, because the magnetic field died out over time. So how could that magnetic field die out over time if it was never there in the first place, possibly? That was one of the questions, right? Well, first of all, here on the Earth, we have 7 different continental plates, basically, and they're always slipping against each other, bouncing around each other, and over time, have changed the way the Earth looks. That's called plate tectonics. Well, Mars doesn't have any plate tectonics. In fact, there's no plates other than one plate. The surface of Mars, is one giant plate. So, near the InSight lander, the crust on Mars is 15 to 47 kilometers thick. That's just over 9 miles and just about 30 miles thick. But here on Earth, it's 5 to 70 kilometers thick, as opposed to Mars, 15 to 47. And that means on Earth, it's 3 miles into the ocean, deepest ocean, to about 43 miles thick on the continents. Now, also on the Earth, we have something else going on, okay? We have that mantle. So we have a relatively rocky mantle below the crust, but then it gives way to this pliable, almost molten plastic rock. That's the mantle, right? The lower mantle. And so as far as we know, okay, Mars' mantle appears to be twice as thick proportionally for its size than Earth's. So that's interesting to us because it also shows that maybe the mantle on Mars is not like Earth's, meaning, and again, we're flying against science, okay? Not science. We're flying against a supposition of science, okay? So what happens is on Mars, when we look at the mantle being twice as thick, possibly, here on Earth, we have a mantle that goes down from a rocky, fairly solid mantle to that molten plastic thing I was talking about. Now, that's the upper solid mantle on the Earth. Then we get down to this more pliable region, and that's called the lower mantle, or the asthenosphere. Okay, don't worry about the words. It's just the way it is. That's the lower mantle, basically. And Mars doesn't have that kind of variation. It may have a transition zone near the core, but it's got this core that's much bigger than we thought it was.
It is a molten core also, correct?
That's right. It's liquid and not solid, precisely. And that diameter is about 1,680 kilometers, which is about 1,043 miles. Okay. And that's a lot bigger than we thought. Earth's core is 3,483 kilometers, I think. Yeah. And about just over 2,000 miles in diameter. And that's the outer core. Okay. But it's also much bigger than Mars because Earth is bigger than Mars. Okay. But proportionally, Mars' core is just less than 25% of the diameter of the planet. All right. And Earth is just about 27% the diameter of the Earth. So they're kind of in line there, right? But the really interesting thing to me, this guy, okay, is that there's no inner and outer core. And that means there's just one oversized molten core. And this has ramifications when we talk about magnetic fields. We know Mars doesn't have a magnetic field, but we know it did. So how did that happen? Well, on Earth, we have that solid core I told you about, and then we have this molten core around the outside, this molten outer core. Well, the inner core and the outer core rub against each other like this. That creates electric fields. All right? It's if you think about it, you have this material that's hot and melted, and it's moving against this solid material. It's going to generate some type of electricity. And when it does, that electricity is, of course, what you have as a result of the electricity is a magnetic field, but on a planetary scale. Okay. So we have this planetary magnetic field. Well, Mars had this at some point, and we call it a dynamo. It's a dynamo effect, basically, for how we have our magnetic field. And it protects us from the ultraviolet rays of the sun. It protects us from the high energy protons and electrons that come streaming at us in the solar wind. It protects us from that. Although it didn't protect Sky Through Livestream West on July 3rd when we had that solar flare. We actually had the telescope get blown out a little bit, but we'll fix it. It's not a problem. You can still use it. So that dynamo at Mars then ended up dying out. But if the dynamo did exist, then it had to be possibly with that molten core in Mars mantle. But as we can see, that isn't a long-term, well, a solution like that wouldn't have longevity, because that wouldn't last very long. Maybe there was some twisting and motion which caused some electric fields planet-wide, which created a magnetic field for a period of time. But then that went away as Mars cooled. So it's almost like Mars was going to be doomed to fail. And for me, I think that's part of the problem, right, about Mars. I just, I'd like to go, but Elon Musk hasn't called me back. He doesn't return my calls, But that's what we're finding on Mars now. We're finding that Mars has a fully molten core, and it's sort of oversized, and it does give us clues about where Mars' magnetic field went, and we'll have more as we learn it. Okay, but now, ta-da! And Daryl said ta-da just in time, because now it's time for us to do something special, and Daryl Mason is going to be in charge of this. That's right. This is time now for our new segment called Deep Dive with Daryl, and we're taking a look at some specific constellations in the summer sky. Daryl, are you ready for this?
Yeah, I'm getting set up.
All righty.
Okay, I guess I'm ready to go.
Go for it.
Here we go. Let's see. Do you see it yet?
Not yet.
Okay. Whoops. Okay, sorry.
That's okay. You see, I built it up, and then all of a sudden it didn't work. You see, that's how it works, though, Daryl. So don't worry about it. Just there you go. See, there it is.
There we go. Okay.
Yeah,
Take it away. Hi, everybody. This is our little Stellarium Sky Tour and deep dive for the week. I'm going to start at about sunset here. You can see the sun is behind that tree, just about to set. And I'm going to advance it a little bit and make the sun set. And first off, I want you to notice that, there we go. Okay, I've been mentioning Venus, and there's Venus. It passed Mars a few weeks ago, and they're both up by the star Regulus in the constellation Leo. Leo is setting pretty early now. If you go out and look over toward the west or the west-northwest after sunset, Venus is brilliant. It's the third brightest thing in the sky right now. And I have been able to see Venus like within about 5 minutes after sunset. So if you have a good horizon, go out and look sort of toward the west-northwest. It's unmistakable when you see it. Interestingly, it hasn't gained a lot of altitude, but it has moved farther south. The sun passed, we had the summer solstice back in late June. And ever since then, the sun has started moving south against the horizon now. So we're headed toward winter. And as the sun slides south, Venus is sliding south with it. So though it hasn't gained a ton of altitude yet, you can see if you watch it over time that Venus has moved south in the sky. It will continue climbing in the following months. So get out and take a look. Mars is so dim now. And it's pretty much lost in the sunset glow. You probably won't be able to see it, maybe with binoculars. But be sure to go out and look for Venus. It's up for maybe an hour after sunset. Okay, we have touched on Scorpius, and I believe Mark did Sagittarius a few weeks ago. And I'm going to kind of focus up a little farther north now along the Milky Way. And I'm going to start with the constellation of Scutum. Scutum. That's how hillbillies say it, is Scutum, but it's probably pronounced Scutum. Scutum is a shield, okay? Like, swords and shields and all that sort of stuff. So that's the shield. And when you get closer to Scutum, hey, there's a satellite. It's a Starlink. And they
figure.
show up a lot. No, yeah. The first thing we're going to look at is M11. Okay. It's an open cluster of stars. Mark has shown you this in the past, and I bet he's going to show an image of it here pretty quick.
When you're ready.
Oh yeah, go for it.
And this is M11.
M11. It's called the Wild Duck Cluster. And, well, do you see wild ducks there? When you see it in the telescope, it looks sort of triangular. And somebody imagined it looked like a flocks of duck. You know how they tend to fly in formation like that. So that is M11. There are other objects there, but we're going to focus on ones that we have looked at. There goes another satellite. TDS-1, whatever that is. Okay, and we'll back out now. And
actually, Daryl, can you just mention one thing?
Sure.
When Daryl says you're seeing the satellites, these are actually accurate. These are accurate. They're called orbital elements that are taken for these satellites. So if you see them like this in the sky in this stellarium, they're there for real. Yep. Just so you know, it's not for show.
Okay, so we'll back out some, and let me get set up again here. So we were in Scutum, and I have talked a little bit about Ophiuchus before, the serpent bearer. He is holding the snake, Serpens. There's another one. This is Serpens caput. That's the head of the snake right there. And Ophiuchus is holding the snake, so here's one half here, the head and the front half of the snake. And over here is the tail, the backside of the snake. It's called Serpens cauda. And we're going to zoom in on that now. And I'm looking for, let's see, I forget exactly where it is inside Serpens cauda. We're looking for M16, the Eagle Nebula, the Pillars of Creation. Excuse me. Mark, help me out here if necessary.
And Mark is on mute.
Yes, I had muted just to keep people from hearing the creaky chair that I have and stuff like that. Maybe if you zoom out a little bit, Daryl. Okay. And you can approach it from just the Lagoon and Trifid region and then go up towards Scutum. Right? There's M8, yeah.
Okay, M8.
And it's going to be
M20.
No, it's to the upper left now. Okay.
Whoa, did you hear that?
Yeah, I did. That was thunder.
Is that from you, Daryl?
There it is.
There it is. Yeah, see? It's right there. Yeah.
Okay. There's, excuse me, M16, the Eagle Nebula, in the snake's tail. And Mark, go ahead and take over whenever.
Sure. This is actually a Measure 16. Yeah, known as the Eagle. Yeah, as Daryl pointed out, and those little fingers you see in there, you saw the Hubble telescope photo of these called the Pillars of Creation, and this is our version that we took with SkyTour Livestream. So all these pictures I was showing you from M11 so far to M16, they're all from our telescope. Mm-hmm. And this was from the East Coast one. The West Coast one, the photo is even more spectacular, if not wider angle. It's just beautiful. But anyway, yeah. So that's Messier 16, the Eagle Nebula, for tonight's deep dive.
Leave that up just a moment, if you would.
Oh, sure.
Okay. Now, something I want to ask. Can you zoom in on that at all, Mark?
I can't. I don't know how that works with this. It doesn't let you do that.
Okay, but folks, do you see the eagle? I see it. I don't know if Mark sees it or not. I think he's had trouble in the past. But if you see that darkest part of the nebulosity there, there's like three parts. Over on the left is the wing of the eagle. In the center, there is the body, the neck, and the head of the eagle. He's flying to the upper right. And then over a little lower on the right side, that's the eagle's foot. Can you see that?
I see that myself. And if the people can see that, then, okay, I was thinking of the eagle as embodying much more of the whole structure. But I see what you're saying, and that certainly looks like an eagle after it caught a salmon.
Uh-huh.
I always see like an angel clasping their hands in front of them.
And there's, okay, you got that too. Yeah.
That's cool.
I see it how Daryl sees it. Yeah.
I see
So
it too.
you
Yeah.
see the eagle. Very good. Okay, I'm going to back out again now, and we're going to move a little farther. We're going up toward Cygnus. See, we're still following the Milky Way. The dark band there, that's called the Great Rift, and that's a huge dark cloud of matter that is obscuring what's behind it. We may talk more about dark objects later.
Yeah,
but we're going to move on up to the constellation of Vulpecula, and I'll put the art in there. Vulpecula is, Amanda, I'm sure you know what this is.
I always call it a firefox, but it's not just a fox, right?
Vulp-
I think of Vulpix, I think of Pokemon, I know.
Uh-huh, well.
See, all the astronomers, they all saw the eagle, and I saw an angel. You're talking about a constellation, I see a Pokemon. Like,
hey,
I'm trying my best here, guys, but yeah.
Talking about constellations, I see a Pokemon. That's funny. That's funny.
And what we're going to look at here is M27.
Oh, yes.
And this is the, I call it the apple core. I found out that other people even call it the apple core too. Mark, you can go ahead and hit that if you want.
Sure, the apple core is a typical name for it, yeah.
It's called the Dumbbell Nebula. It's a planetary nebula. You can see the little star down in the center. That's the white dwarf, what's left of the star after it blew off its outer atmosphere. It's mostly in the light of oxygen-3, a little bit of reddish helium, or excuse me, what is it, neon or hydrogen there on the edges.
Yeah.
I always see that as an apple core.
Yeah, it certainly looks like one. You know, and I like people to understand too, like planetary nebulae are the gentle ways that stars go.
Yeah.
So when the layers actually, the star originally, before it was a white dwarf, it was a red supergiant. And the outer layers of that red supergiant got so far from the inner star, the inner core, that they reached a point where the slightest additional stellar wind from that star could push those layers away, and they wouldn't be gravitationally bound to the star. And that's what happened. So it was a very gentle sloughing off of these outer layers. It wasn't a violent pulsating explosion or anything. It was just a gentle sloughing off. So it's a gentle way for stars to go. And that happens with stars that are lower mass, like around the mass of the sun, say, because we'll never do anything but like this kind of thing. But Betelgeuse, on the other hand, like we've talked about before, that's going to go in a supernova, and that's going to explode, explode. But I'm wondering, are we doing we got a break coming up, don't we, Amanda?
We have about 2.5 minutes.
Okay,
Look at this. I'm so not needed here anymore.
Not true. All right. Well, anyway, but so this planetary, there's many planetaries in the universe, and they're beautiful, and we look at all of them. We can see from the Sky Tour observatories, and we'll be showing them to you in detail. And of course, you can hear Daryl Mason with us because he's part of the Sky Tour live stream team, as is Amanda. So you can check us out whenever we're out there, and we'll do this on clear nights. Right now it's monsoon season, as Tara will tell you. And Tara is amazing for helping us with the observatory. She is a diehard supporter of Sky Tour live stream.
You bet.
Yeah. But anyway, Daryl, it's back to you. Yep.
Oh, well, okay. Am I up here? Yeah. Okay. All righty. And then we're going to move from Vulpecula the fox, the little fox is what the name means, on up to Lyra the lyre. You can see it's sort of like a harp. It's a musical instrument, and the bright star of Vega is up at the top right corner of it. And then the last one before break, we're going to zoom in right here. If you see that parallelogram shape there, right in between the farther two stars, okay, there is M57, the Ring Nebula.
Right.
And this is such a cool object. It looks like a big smoke ring out in space.
And there it is.
Go for it, Mark. There you go.
Yeah. Now, just for folks to know, StreamYard tends to lower the resolution a little bit. There's a central star in this one, too, just like we had in the dumbbell here. You see that central white star in the middle. Well, Messier 57, the Ring Nebula, has it, too. And outside StreamYard, it's there. But here, for some reason, because it's a single point, it's very small, it gets destroyed with the compression algorithm that StreamYard uses. But no big deal. Again, a planetary nebula. I think that it... Daniel,
really nice. No, thank you for sharing, Daniel. If you guys ever want to share anything, we are keeping an eye on chat, and I love this community. Thank you for sharing, Daniel. I hope it's working out for you. If you're on Facebook, we do have a Facebook group, Sky Tour live stream, Sky Tour live stream with Mark D'Antonio on Facebook, and feel free to post your pictures. We do. He puts them in unprocessed, so you can take them raw and have fun with them.
I see it's break time.
Yeah, and more on that after the break. So go check out Facebook while we're on this commercial break.
We'll be right back, ladies and gentlemen. Thank you.
Hey members, the new KGRA-DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA-DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA-DB.
I don't want to talk about it.
I don't want to talk about it.
Families don't have to talk about everything, but they should talk about how to plan for an emergency. Get tips and resources to make your family's emergency plan.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Hey, welcome back. And we're in the deep dive with Daryl. And we're going to continue where we left off. We were talking about the beautiful Ring Nebula, which is a beautiful planetary nebula. The remains of a star, has a white dwarf at its center. And I believe Daryl is ready to pick it up and go. So take off, man.
Absolutely. Okay. We're hopscotching around some tonight. I am going to move over to one that we have neglected, which is Hercules. Hercules, he is just to the west of Vega. He's sort of between Vega and Arcturus over in constellation Boötes. Hercules, he's the tough guy. He's half god, if I remember right. He had the 7 labors of Hercules, which helped demonstrate what a badass kind of guy he was. I want to particularly talk about M13 here. M13, the Great Northern Globular Cluster. Once upon a time when skies were dark and I was still young and pretty, I could actually see this with the naked eye from a dark sky location. Those days are beyond me, and the sky pollution's gotten so bad here. But it's still a knockout in the telescope. And Mark, you want to put that up?
Sure, there it is.
Okay. This is hundreds of thousands of stars all clustered in a ball, a globular shape. We were talking the other night. I think we might just barely see what's called propeller, which is sort of a dark feature. I think that's it on the right in this image. It looks like a 3-lobe propeller. It shows up really obviously in some pictures and not so much in others. I was looking at a bunch of pictures of M13 just recently, and I almost think the propeller shows up better in old-fashioned film images than it does in modern digital images.
Yeah, you mentioned that the other night, and that could very well be true, you know?
Yeah. If you could zoom in on it, though, and hopefully if you see it in the eyepiece through a telescope, you will see the propeller. It's a rather striking image.
Yeah, when you take a time exposure like this one, you sometimes lose some of those subtleties. So that's a place. That's actually a time and an object where you probably need to see it live in an eyepiece rather than, in a photograph. We use it. We can see it with the live cameras as well, and you might be able to see it there.
Mm-hmm.
But what's interesting about globular clusters, and I don't know if you were going to talk about this at all, Daryl, but the globular clusters are among the oldest objects in the universe. And this is one of many, many globular clusters around our galaxy. And they're also called halo objects. They are actually outside in general. They orbit the outside of the galaxy. And they're really odd. It's to try and understand where they come from is an ongoing debate, but they're there. And the stars we know are very old because they don't have a whole lot of elements in their spectra. The sun has many elements in its spectrum.
Aren't globular clusters thought to be actually older than galaxies?
Well, I mean, they're in the order of 12 billion years old in general. I mean,
Yeah.
and so galaxies and the formation of galaxies probably occurred sort of concurrently, but I'm not sure. In some cases, maybe there's galaxies that formed after globular clusters formed, and maybe later. I mean,
they're certainly very old stars. I know you talked earlier about the prevalence of different elements in the universe. That after the Big Bang, it was mostly hydrogen, some helium, and I believe just a little bit of lithium was mostly what existed before the stars had time to cook up new elements via supernova, etc. And these are older population stars. There's 2 kinds: population 1, population 2, and the population 2 are actually the older stars, correct?
Yeah, and that means we call them metal poor, and for astronomers who love to confuse things, it seems. Anything other than hydrogen and helium is considered a metal. That's just, think of it as a word. It's called a bob. Just may give it a name. It's just not hydrogen or helium, so it's all the other things. Okay, but in astronomy we say metal poor.
Yeah, lithium in its pure form is a metal. Actually, it's the lightest metal. Okay, you want me to carry on now?
Sure, go ahead.
Very good. Whoops, I just lost something. Are you still there?
Yeah, we're here.
Let me check. Okay, I got too many windows open. Very good. Here we go. Let's see. Oh, darn it.
So
What
we were
happened?
focusing on Hercules, and we saw Measure 13, the Great Cluster, Globular. There's many, many others, including Omega Centauri, which is Daryl's favorite globular cluster on Earth, I believe. He thinks that's the greatest cluster there is. I've never seen it.
I saw Omega Centauri once, way down in the southern sky. Okay, bear with me a moment. I actually closed the stellarium. Clicking around
You did?
too much. Yes.
Okay. I see it.
That's a funny choice of wording. It's Daryl's favorite cluster on Earth.
I know, right?
Yeah.
I was waiting to have someone pick up on that.
In case, for those not paying attention. Daniel wants to know, wouldn't the stars in that cluster only be light months apart?
In some cases, that could be true near the center, Daniel. But the other thing to consider is that, and actually, in a little while, we're going to take a journey into the middle of a globular cluster, and you'll be able to see what it looks like to be inside the cluster, looking out and spin the universe around you. We're going to be doing that soon.
Is there any such thing as a light day, or is that just too small a fraction of time to even?
Well, I mean, there's light seconds, so there have to be light hours and light days, right?
Yeah.
Okay, I mean, Pluto is light hours away.
Can you have light nanoseconds?
Yes, actually.
You're just making things up.
No, not at all.
Because of the arcs on the Earth?
No, because of the speed at which light travels, right? 186,282 miles per second. That's 7 times around the Earth in a single second. Okay, if you could make it go around the Earth. Hey, Daryl's back. All right, Daryl.
Okay, I'm sorry. Okay, so I'm hop, skipping, and jumping all over the place here. The last thing I wanted to mention tonight, this is one of Bill's favorite things. The Perseid meteor shower is coming. There are early. I'm sorry.
When's that going to be?
It will peak the evening of August 11th, morning of August 12th, or possibly on the 13th, depending on who you listen to. The Perseids have a very broad peak, so will probably be visible both nights. Actually, the Perseids are already, some early ones are visible. The Perseids are debris from Comet Swift-Tuttle, which the last time it came through, I believe, was 1992, if I remember correctly. Okay, anyway, if you can, we're looking north now, and it's a little later. Right now it's a little after midnight, but here comes Perseus, and by August it's going to be higher in the sky. Perseus will be rising about 10 o'clock or so. But if you can see the W of Cassiopeia, that crooked W shape, it'll be up in the northeast, and Perseus follows Cassiopeia into the sky. I turned on the art so you can kind of see his figure there. Those 3 stars right there on the end, going to zoom in some. This is one problem I have with Stellarium, is the artwork doesn't really match the constellations that well sometimes. You see those 3 stars in that little triangle. That is the magic helmet that Perseus wore that made him invisible, if I remember correctly. And in his left hand, that's the head of Medusa, the Gorgon, the woman with the snake on her head, the snakes in her hair. And that's represented by the star Algol, which means the ghoul or the demon star. But anyway, if you can see that little triangle of stars right there, the radiant point of the meteor shower is right there. It's generally said to be just to the left of the head of Perseus. And if you go out and you watch the meteors, and if you trace their direction back across the sky, you should be able to see Perseus anywhere and everywhere in the sky. But if you trace them back toward the direction they appear to come from, if they radiated from that point, well, it's a Perseid. And that's something to look forward to in the next couple of weeks. Again, you may see some early ones right now. They're going to get more and more each night until the night of the 11th, 12th in the morning. Meteor showers, the Perseids being a classic example, are generally best between midnight and dawn.
Right.
And if you see a meteor streaming from this direction where my pointer is, hey, it's a Perseid. I was reading the other night, there's actually another meteor shower that's building right now. I think it's called the Alpha Capricornids, which is way back over this way. And you may see some of those or other spurious meteors that may appear anywhere in the sky. But if you can trace it back to this point right here, you've seen a Perseid meteor. There should be maybe 100 to 120 meteors an hour at peak. It's called a zenithal hourly rate, which means perfect conditions. But you should see a ton of meteors. And the moon will have set by the time Perseus is rising. So we're going to have a really good look at it this year.
Yeah. And well, I wanted to mention too that the meteors can generally be a bunch of different colors, but these typically are a beautiful yellow color. And if you can see them after midnight, then what happens is they're actually, in a sense, catching up to the Earth, and they actually are going to enter the Earth's atmosphere slightly slower. And they may, and I've seen this happen, they may take their time moving across the sky, in that they might cross your sky or go through, say, 50 to 60 degrees of sky in a period of something like 4 to 5 seconds. And they might even leave a trail behind them that you might be able to see.
Yes.
And this I've seen as well. And one famous Perseid that I saw, it left a smoke trail behind it. And it also visibly broke up into 3 large pieces that I could see from the ground. It was really the most stunning meteor I've ever seen in my life.
Yeah.
Yeah.
I've seen different colored Perseids. I've seen red ones. I've seen white ones with a red streak through the middle. Seen yellow ones. Very colorful, and a lot of them are very bright. I used to do a public program each August about the Perseid shower. I did it for the state parks.
Mm-hmm.
And people, this was down in the San Juan Mountains in southwest Colorado, out in the boonies, and had a great sky, and people just got thrilled every year because we saw tons of Perseids down there. If you can get out of town for the shower, more power to you, because the darker the sky you can get to, the more you will see. But this is something to look forward to in the next few weeks.
Right.
And don't they advise that, like, if you're looking at anything in the night sky, to wait about 20 minutes to let your eyes adjust to the darkness?
Absolutely.
So if you go for like 5 or 10 and don't see anything, don't get discouraged. Be out there for at least 20 minutes, let your eyes adjust. Obviously, the closer, the further away from like city lights and light pollution, the better, obviously. But just stay safe while you're out there.
Yep. And there used to be an experiment we used to do where you could put out a sheet, a square sheet of fabric, and in the morning you go out there and it's covered with dust, some type of black specks. And what you can do is you can actually take a magnet and run it over that sheet. And the things that stick to your magnet are very likely meteoritic dust from space that has filtered down, because the Earth, gets many millions of tons of stuff a year in meteoritic dust. So it's accumulating all the time.
Yep.
It's pretty cool.
Yeah, they say put a magnet in a bucket and put it under the spout on your gutter, and if anything sticks to the magnet, it's a good likelihood it's a meteor.
That's right, and you had the whole surface area of the roof to work on, to work it out. Yeah, but you know what? In these days with industrial pollutants, what happened?
More thunder. You talk about the monsoon; it's happening right now.
I know.
Yeah.
I was checking the SkyTour Livestream West site earlier, and I sent a photo to Tara, who of course is helping us greatly with it, and I sent it to Marianne Robb, who's also helping us, and It's
And
actually
Marianne was in chat earlier. Hi, Marianne, if you're still there.
oh, very good, Marianne. Yeah, she said she was going to put this up on the big screen because we're getting to the section where the big screen is going to be helpful. We're coming to besides the Stellarium part, which is beautiful on the big screen, we have another section that we're coming to now. But that said, I think that meteoric dust is something that's really cool to try and gather. I would love to hear if people can do that with their magnets. And if you move a bar magnet across a sheet after the night, if it's laying out in the backyard, you'll be amazed at the fact that your bar magnet might have some meteoric dust on it. And I think that's pretty cool. Very cool. You know. So, so I assume now you're set with Stellarium. You're done with that segment now, Daryl?
I am.
Okay. Well, thank you very much, Daryl. Yay! Shh. Well, the crowd are
I
going.
think that's one of the crowd's favorite segments, actually.
It is.
Being able to.
Very cool.
I hope I don't bore people.
No, you have beautiful analogies. I've always said that you really bring things down to, people like me that don't, I need like something I can visualize in my head, like in the real world. So
that's right.
Yeah, and that's why these sky tours are so fun, even if they're virtual. Just looking at whatever you want, examining it, looking at different angles. It's amazing the technology we have now for this kind of stuff. So, thank you.
That's right. And if you're stuck inside on a night where it's not very where it's not very clear out, then what you might want to do is to try and find an astronomy program to hang out with and enjoy. And I think it's pretty cool. And what I want to do right now is to actually bring up something like that. This is a product that we use to help us visualize the night sky. It's called Space Engine. And it really is very, very cool. We can fly around the universe with this. It's all in 3D, and it's believably beautiful. What I'm going to do is I set up a few things. I wanted to talk about some lunar craters first. And so we're going to just jump to the moon in order to save time. And then we're going to go on a little spelunking tour to try and check out the moon. And the particular crater we're going to go to is one that Daryl and I talked about for about, 45 minutes yesterday?
Something like that. Yeah, I thought it was fascinating. Hopefully the crowd will enjoy it.
Yeah, the Messier crater. And I would like to know why it's not working. Where's the textures? Okay, I should be seeing them. Let's hope they're going to pop in. Wow, look at that. Okay, live radio. That's how it works. Ay. All right. We'll tell you what. We're going to come back to that, and I'll make sure that it works. But it did not. It's somehow, I don't understand why, but somehow the textures are not working. We have a beautiful moonscape here. We should be able to see all of these things working just fine, and it's not. But that said, Messier crater is one that the Apollo astronauts photographed. It's one that's been seen by people, for millennia. Okay, and here's the crater. Okay, it's an oddball crater. It's actually two craters, right? This lower one that you see in the image there, that's a Messier, and the one above it is Messier A, I believe. And, you see craters like Tycho, right? Tycho crater is a crater that actually, has these beautiful ray structure. And that ray structure that you see is something that emanates away from the crater in like all directions, basically. And so when we look at things like Messier, this crater, we're seeing something that's really odd, aren't we? We're seeing not rays that are radiating away. We're actually seeing rays that are going straight out from the end of the crater, And the reason that happened in the way that people discuss it is that this was created by an impact by a very low elevation angle object, or more than one object. What's funny is Daryl and I were talking about how how such a crater could get formed last night. And we figured, well, in the first crater, the one at the bottom, obviously the crater was made by an initial object that strikes. But then we figured that it's going to basically bounce out of that crater that it made and then bounce up above the moon and then hit again and possibly dig in, as Daryl had said yesterday. But when it struck the first time, maybe it broke into pieces. And when it struck the second time, there were two pieces that may have hit and caused those rays to be like a double ray, like you see here. But the thing is, when you look at this, that double ray structure is something that is really fascinating. And when you look in the middle of the crater, just above the top crater, just above the middle of that, like in between the rays, there's like a raised ridge. And that raised ridge could be the result of potentially the object itself digging in and going underground. And so this was a rather fascinating thought, because if it means that the object is still there, when you see craters around the moon, most of the craters that you see are all craters that have been caused by high impact energy strikes, right?
Now, is that going to be one specific kind of impact? Because Oja's wondering what would happen if a huge comet hit Mars. Is it like, do different things cause different kind of indentations? Do certain things break up and would never come in contact with Mars? Or is comet different than asteroid pieces? Or, you know what I mean? I'm assuming these are asteroid pieces that hit this, but I don't know.
Yeah. Well, it's go ahead, Daryl.
I'm sorry. At typical velocities, both asteroids and comets, when they hit, I mean, they're going to basically vaporize and they're going to blow a crater out, and the ejector from the crater is going to go in all directions. We were talking last night, and whether it was a comet or an asteroid, there may be differences in how the explosion and the ejecta happens, but I would think at typical velocities, both of them, I mean, they're going to vaporize and just turn into a big, huge explosion.
Right. The impact.
What we were looking at last night, I was thinking it's almost like the thing was moving so slowly that it skipped like a rock on a pond, at a shallow angle.
Yeah.
And it hit the first time. And if you look carefully in that image, you can see ejecta to either side of that oval impact. Like it didn't spray all over, but it went to the left and to the right.
Yeah. Now, what I can do there, Daryl, to help out is I can bring back this guy. I believe we have it back.
Go for it.
And so this is the moon. I have a very high resolution map on it. And what Daryl's talking about is, okay, this is the crater right here, and we're looking at it in 3D. It's a beautiful product for doing this type of thing. And there are the ray structure that you see there. And what he's talking about is, here's where the first impact occurred. And when it struck there, you see stuff that's going out to the side here. That's actually rather interesting. And, that stuff on the side is material that was plowed. It was plowed out of this furrow by the impactor. And then it spread to either side. Now, keep in mind, okay, here's a crater up here, okay, that's actually round, okay? This is actually a round crater, right here. So that means that the impact was such that and people think, well, it hit head on. Well, it doesn't have to hit head on. It could hit in a glancing angle, but if the energy is high, it'll still make a round crater. How do you know this? Because when you skip a stone on the water, you can see it happen. If you skip a stone on the water, it goes ding, 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 and it goes along the water. And as it does, everywhere it skips, it leaves a perfectly round concentric ring as it skips across. But at the end, where it loses energy and runs out of energy at that shallow angle, then it drags out an elliptical splash at the end and then sinks. And that's kind of what we see here. It looks like that to me. This is kind of what it looks like to me. We're looking at the same kind of thing. This is a low energy impact, and the impactor was not destroyed. In fact, I think the impactor is still underground here, underneath the surface. And if we actually, head along here and check out this area, you can see, okay, that the impactor may very well be right under here. It might have plowed up this edge. And this little area right here that we're looking at, if I can just grab us over there for a minute, okay, this little area right here, all right, that we're looking at, which is right here, that's a raised ridge. And if we were to just come over a little more this way and drop down, all right, now we're looking down the crater rays. There they are, all right, but let's go down in the crater. Let's go spelunking. If we go down into this crater, right, come right down, and let me just go a little quicker and then slow it down. Okay, now you can see this raised ridge right here. And you can see these two trails right here leading out. This might be the result of the splash, okay? And this might have been a plowed area created by the actual projectile that struck. And that projectile might be under here. I would love to find out if that's true.
Yeah, I know we saw last night, and if you can maybe raise up a little bit, you'll see that raised ridge area there looks almost like it's perfectly aligned with the two parallel rays moving off from it. Almost like, the material went to either side because that ridge was in the way.
That's right. That's exactly what it looks like to me too. And I'm pretty sure that this is probably a very important genesis for this particular crater. Now we also have to keep in. What's that?
I was going to say, I actually misspoke. Again, it might not matter because, an impact is an impact depending on, regardless what it comes from. I thought he was missing letters on his keyboard and he was trying to spell comet. He meant CME, coronal mass ejection. Oh. Is that possible to reach that far? If so, what kind of impact would that make? Same as anything else hitting it, or?
No, actually. A CME is different. A CME is very highly charged particles, of course, but it's also material from the actual sun. Okay, plasma. Okay, and these objects, this CME material, it's not going to cause craters or anything like that. Okay, like we see here, right? This is a crater caused by an impact of a physical object. Well, the CME is not so much a physical object. And what it will do is irradiate and cause all kinds of radiation effects on the ground that it's hitting. But it's not going to gouge a hole. It'll send charged particles down into the lunar soil for sure. And those charged particles could generate some type of effect, I guess. But I don't believe that the CME, the coronal mass ejection, would actually do anything like we see here on the moon. It wouldn't create any kind of craters. Okay. But, because, again, we're looking at the sun. It's plasma, very high energy plasma. And the definition of plasma is just, loose protons and electrons flying around.
Okay. Kathy wants to know if the rays are ejecta from the impact.
Absolutely, They are. Very good, Kathy. That's exactly what they are. They are ejecta. And so if we were to, come along here and follow this, okay, we would go several hundred miles on the moon until the rays sort of die out in their intensity. But that's what they are. Excuse me. So there we go. And that's one of our favorite craters on the moon.
Hey, Mark, I have a question. The ejecta that went to the side, it looked like there was some perpendicular rays coming off of that. Was that from like an older impact or something, or was that from the same event, do you think?
Well, it's interesting you mentioned that, Tara. I'll tell you why. Because one of the things that one of the theories that exists for what's going on here, all right, is that when we look down at this impact here and you see these transverse rays coming off like this, one of the thoughts was that this was one impact and that this was a second impact, that maybe there were two objects that collided and they were moving at slightly different speeds, slightly different angles, but basically were based on the same object. And that's one of the theories as to potentially what may have caused this to look like this. I think that's where you were going with that question, right?
Well, it seemed like to the side of one of the first impact crater, there was some perpendicular rays that were coming through when you were looking at it from the other angle. And
you
they're
mean
kind of hard to see.
These
yes,
rays?
but there were some that were perpendicular to those, yes. That were
Okay.
up to the top. So I thought I saw some. So
Right.
but it's like what you were saying, it's probably from another impact from before.
Yeah, we got to keep in mind that what we're looking at here is something that has had billions of years of weathering and further breakdown by solar radiation affecting it, and further impacts and dust sifting down from other impacts elsewhere on the moon that has literally gone up into the exosphere around the moon. I can't say atmosphere because there is no atmosphere. And so knowing that, we look at an impact like this and say, well, we're only seeing the end result. We don't see what happened to get to this place. But, these
Isabella,
features... Yeah.
Sorry, go ahead.
No, you were going to say, go ahead.
Oh, Isabella just wanted to know which of the two craters was deeper. I'm actually the first one from the impact, but maybe that's not true.
Well, that's the thing that Daryl and I were talking about yesterday. We had an interesting thought about that, Isabella. Thank you for the question. And one of those things was, when we looked at this crater, I was looking at it saying, well, this one here is longer, but this one looks like it was more damaging. So it's almost like this one here was like a glancing blow, and this was the final blow. Yet, this is a scour. This is what we call a scour. It goes right along here. And if you go down in here, I mean, you can literally follow this material along, and you can actually see that it's actually, goes right down, and it's pretty deep, So we're inside this scour now. Okay. And so, then you come out of it, and now it bounces up in the air. And then the idea is that it hit over here, and I think it actually came down in here and just, and stayed here. This, I think, is where it ended up. And billions of years of erosion, say erosion from radiation, not erosion from wind or anything, ended up covering it up. And this flat bottom is from the sifted down slumping from the sides of the crater and so forth. Go ahead, Amanda.
Okay, and you might have already touched on this, or I'm trying to grab links and watch chat and everything. Okay, let's say it was a piece of an asteroid. Like, if it hit Earth, there would be like a physical rock, right?
That's correct.
Is that what you're saying got buried as well? Do you think it's under the bridge? Okay. I
actually think that there's at this particular case, I don't think the impact energy was high enough to vaporize this. And Daryl was alluding to that earlier, and we're in agreement. There's probably a solid object under here that could have snowplowed this material up here. See this additional ridge?
Yeah. Okay. Like I just wanted to make sure that's what you meant, that it wasn't just falling in on itself. Yeah.
Yeah.
Now, if you look at both of those, I don't know if we could back out a little bit. I think the rays from the first crater are transverse, and to the rays from the second crater, they almost make a perfect T shape. Mm-hmm. And to me, it's almost like when you see a water skier jump and hit the water again, that, we were talking about a typical ejecta pattern from a crater should be all around. Yet with a glancing enough blow like that, imagine that's a big water skier that just landed in the first crater. The water is going to go to either side.
Yes.
And then when it dug in and hit the second time, it pushed up that the big lump at the far edge of the second crater and may be buried under that. and then whatever that ridge is or was actually made the dividing mark that splits that ray in two.
And that's the reason, actually, Daryl, yesterday when we talked on the phone, that I suggested that maybe the impactor was actually more flat.
I
Because
always
then it would have done that splaying out on the sides like that.
Yeah, I almost see it like a football shape.
Yeah, you mentioned that, when we talked, and I think that a football shape is also possible, but a football that landed with its end to end going left to right in this image here at that point when it struck, maybe. Because, I think that a lot of the energy went to the sides here. And I think much of that energy was probably dissipated as it then got to this next spot and dug in. But this was almost like a glancing impact. And, I actually think another thing we should do, not tonight, of course, is to look downrange to see if there's any indication downrange that there might be some type of additional material that was deposited down there that we've just not seen.
Yeah.
Well, that's what I was wondering.
Were you, Amanda?
Well, that's what I was wondering, but I figured if you guys were already here, you would have followed that path all the way until it faded away, or...
There's one crater right up there toward the lighter area that's almost perfectly in line with the rays. Maybe that was...
talking about this guy right here.
So, but we can only...
And then there's one about twice as far away, too.
Okay.
So we can only see what we've, visited, though, right? And everything else is just artist interpretation?
No, this is actually real imagery that's been...
that crater right there.
Yeah, right here.
No, farther up.
Oh, you're talking about up here.
Just above that line right there. Not that
Right
far, right there, right in the middle.
Okay.
That lines up with it also.
Well, we have a series of crater pits here, but I think these are those pits, and I know that's not what you're talking about, but I think these pits are probably collapsed lava tubes.
I agree.
Yeah.
No.
Well,
just a thought. I could imagine one day when we're on the moon and mining and all that stuff, if they go dig into Messier A, if they can still find the asteroid in there.
Yeah.
And boy, like people talk about the quintillion-dollar asteroid that Elon Musk wants to find, that there may be a great big chunk of, valuable minerals there that
I think that's true.
They could
He's
tap
probably
into.
right. Yeah.
Anyway, Messier is too cool. It's one of my favorite objects on the moon.
Yeah, mine too.
Ringo, Genghis was wondering if, and maybe you guys discussed this yesterday, what if the object was spinning? Is that a possibility? Or?
When Daryl and I talked yesterday, I said I said to him, I think that meteor strike pattern is indicative of a spinning object. Okay, and I did feel that it could be spinning. So Genghis, you're right on the money. I do believe that this one here could have been spinning, and that could have caused that to happen, and then it struck here, and then created that. Maybe when it struck here, it altered its spin from side to side to end over end in some way, and that could have caused more of these rays to be spewed out this way. I think that's pretty cool.
Well, I don't know why, but when you were saying that, it made me think of like a car crash, like in the car racing, like when they're going around the laps. Like first they start going to the left, and they start spinning in circles, and then the car starts flipping like sideways, end over end. So something like that, if it stops on a certain angle, it could be propelled a totally different direction. And it's crazy how much you can deduce just from looking.
I know.
Not witnessing, just what's left, like something like a detective would do, space detectives.
That's exactly right.
It'd be a new segment.
I've been a space detective since I was a kid. I've been trying to figure out things like this for years, decades.
It's fun.
Yeah.
And anyone can do it. You just look and think and use logic, and nice little brain teaser.
Yeah. Well, and like any space detective, I mean, what you have to do is keep your mind active, and you also have to, do your best to find answers to questions.
And keep your mind open.
Yeah, that's right. And speaking of questions, I know we have someone with us who has all kinds of really good questions for us tonight.
Yay.
And I think I'd like to segue now into that segment with Tara. This is the Tara's Cosmos. It's a segment where, Tara asks questions that everybody wants to get answers to. And we'll be doing more of this and, hiking around the universe in the future. We're going to be doing a lot of this. This is going to be a lot of fun now that we can. All right. So that said, I'd like to bring up everybody again, and let's take care of saying hi, Tara. How are you? Thank you for joining us.
I'm glad to be here. This is really cool. Very interesting.
It is. It's so much fun. It's almost easy to get lost in it too, actually. So we got to be careful,
Yeah, you could fly on that moon all night long and just
and other moons, because we can go to exoplanets on this as well.
Cool.
So that's something else we're going to be doing.
The landscapes are incredible. How they're so smooth in some areas and so barren and bleak, and then there's just so many impacts. It's really cool.
Absolutely. Yeah.
I like that.
So I hear you got some questions for us.
I have just a few. And okay, in no particular order. I was thinking about the recent space launch, the people that just went up into space and the Amazon guys. So I wanted you to talk about that, Mark, if you would. Because there was some citizens going up. They're all astronauts, I guess, now. But I wanted to know, what do they feel when they're in space? When they got to go up there and launched for a few minutes, what are they feeling? Or what do the astronauts feel when they're in space? How do they feel?
Well, let's take it from the point where the engine's cut off and you're actually in Earth orbit. What does it mean to be in Earth orbit? It means that you're actually moving in a circular path around the Earth, right? And that circular path around the Earth, like this, okay, move you. That circular path around the Earth is going to basically be this. You're moving this way horizontally at exactly the same rate that gravity's trying to pull you back to the Earth. So that means you're going to be moving in a circle. So you're moving this way, but then gravity's trying to pull you, but you're moving this way. So it's going to constantly be trying to pull you back to Earth, but you're in a circular orbit. What does that mean? It means that you're constantly in a state of falling. And when you fall, you know how that feels. When you go over the roller coaster, as soon as you're falling, your stomach goes up in your throat, right? How fun. But 24 hours a day can wear on you and can make you less efficient. So, and that's the thing, they're constantly in a state of falling. So that state is one where they're going to have, for instance, their organs are now free to move around. The fluids in their bodies redistribute and go to places it doesn't normally go to, because gravity keeps the fluids at a certain proportion in your body. But when the heart pumps the same rate up in space, well, now those fluids can go into your head, into your fingertips, into your arms, in the same at a far more prodigious rate, because now the heart is way more efficient in space, right? So the first thing that people may get is a headache, and they may feel like their head is stuffy and full. They might feel uncomfortable, nauseous. They might feel fatigued and dizzy, in fact. So, or have, like I said, they have like migraines or headaches too. So it takes some getting used to. And so for instance, when Branson went into space, he was weightless for basically a few seconds, right? I mean, I forget how long. It was a minute, was it? And Bezos, about a little longer, I think, about the same. They went up a little higher. But they were in free fall, and when they're in free fall, that's when they're weightless, and then the drogue chute comes out and bam, they'd slam down to the ground, and but it's different from the way the shuttle was. When the shuttle came into Earth orbit again and started coming in, you could have a pencil floating right in front of you in Earth orbit, and as the shuttle re-enters the Earth's atmosphere, the pencil doesn't fly all over the place, okay? It stays right there and just gradually starts to fall down until it's now resting on your lap, okay? So gravity didn't just instantly come back. It came back gradually over time. So you would end up feeling the onset. Your legs would get heavy. And if you were in space for any period of time, you might find it was actually quite difficult to lift your legs off the chair and to get out of the chair. and many astronauts have experienced that, and that's why you always see astronauts being helped out of the seats and helped and sitting in chairs, especially when the Soyuz lands after the ISS landings. The astronauts are carried out and sat in chairs to do a press conference right there on the steps in Russia. So, and this happens because they can't walk on their own at this point because they've been up in the space station for a few weeks. That's kind of debilitating. The muscles atrophy almost immediately, and have to get
why
it back.
they exercise too.
They do. They use the band exercises, the strength bands. They had designed special bicycles to ride, but it replaces some of the lost mass, but it certainly doesn't keep up with it. So they're constantly falling, Tara. And
Well, they're not weightless,
no, that is weightless.
but they're constant. So if
They're
what
falling
if they're
because
not?
of the space station. It's all relative because the space station's falling at the same rate that they are. And when I say falling, as it's going horizontally, it's also being tugged on by gravity. And if you get a certain horizontal speed, you get it to the right speed, then you can negate the fact that gravity's trying to pull you back to the Earth. And if you go exactly the right speed, then you can go around the Earth in a circle over and over endlessly. And that's what we call the orbit.
Orbital velocity, 17,500 miles an hour.
For the ISS at 252 miles up. Yeah, something like that. And as you get higher, that orbital velocity gets lower. As you get lower, the orbital velocity gets higher.
I always thought you made the roller coaster analogy, when you crest the top of the rise and you get that feeling in the pit of your stomach.
Yep.
Imagine feeling that 24 hours a day. It does at the end. And some people really have a bad reaction to that.
Yeah, I know one guy that went up in the space shuttle, and he basically could not enjoy it. He basically was sick the entire time.
Party.
The other thing you get is motion sickness, too. Motion sickness because there's no up or down. Here you're sitting in front of your screens, and all of you listening and watching are sitting in your homes looking at your phones or whatever. Just imagine if they were slowly spinning around in front of you, okay? And there was no up or down, and imagine that other things were spinning the opposite direction around you at the same time. I mean, you're going to get motion sick, and that's one of the biggest problems in there. And so you've got to focus on an object to try and recover. And sometimes they just sleep because it's fatiguing to the physical body to have to try and focus on what's up, what's down. So
yeah, I've heard that either most astronauts either leaving Earth or returning to Earth. Something about the motion that they will physically vomit. Either at one point or the other, it's just something that like you said, it's too harsh on the body, and you can train as much as you want, but how do you ever really get used to that feeling, right?
Yeah, it's pretty. Yeah, it's pretty bad, and I mean, even veteran astronauts get motion sickness too at times. I mean, it depends on the conditions.
But it would have been fascinating for experiments the first few times.
Well,
what the effects of the body in space vomiting, and where does the vomit go, and how does that move in front of you? And sorry, yeah, Sunday night.
See, in
they
space,
had the airplane they called the Vomit Comet.
I was about to mention that, yeah, exactly.
Where they fly up and they do a big parabolic arc up in the sky, and they achieve weightlessness for a while.
For about 20 to 25 seconds, you're weightless, yeah. And they do it about 15 times. And anyone can do it, by the way, just so you know, listening.
Has anyone survived without losing it?
Oh, absolutely.
15? Yeah?
Stephen Hawking did. He was up there, too. He rode the vomit.
Well, he's the man.
He was.
Of course, if anyone can do it, he can. He's smarter than any machine we could.
Yeah.
Smarter than any machine we could come up with.
Yeah. The thing that's interesting about that is Daryl mentioned, the Vomit Comet, there is an official KC-135, I think, that's got wall padding inside, and they fly in a 45-degree angle up, and then they say, go over the top. The pilots are pushing the sticks forward. When they do that at a certain rate for a certain amount of time, you in the back cabin, you got to lay down on your back on the floor. Okay, you'll start to rise off the floor, and you'll feel that thing in the pit of your stomach, and you go, wow! And the first instinct is to yell or whatever. And so then you're going to play around. You have about 25, 30 seconds of that. and then they'll tell you to get back down, or grab something, stand up, do whatever, because the plane's going to hit gravity again as it comes off that parabolic top of the curve, and then as you come down again, it's going to dive down, and then it's going to do it again and again and again. So that's like going on a ride that makes you sick 15 times and you can't go anywhere or get out of it. You can't ask them to stop the ride, right? Well, I want to do the Vomit Comet. I mean, anyone can. You can go. There's one in Las Vegas, and it is one of these things where you can pay to play, basically. So that's one of the things I'd like to do at some point is take the ride on the Vomit Comet. And in space, you don't throw up.
I don't know if I should ask you to film that to prove it, or
I would absolutely film it, even the bad parts. But remember, in space, you don't, and when you're doing that weightlessness, you don't throw up, you throw out. So it just goes out, and it just keeps going, until it hits something it shouldn't, like a control panel or something. So in space, you do have your own personal bag, that you can use, and it's actually special because you can't just have a bag, because if you do anything down into the bag, it's going to shoot back up and hit you. When you open the bag or close the bag, it's going to come out the top.
So
there's nothing to
technically,
if you take care of it.
If you were floating and vomiting, you could kind of like spin yourself like a ballerina and do a Linda Blair from Exorcist, right?
Oh, why did we do this? Yes.
I'm so tired. The imagery you're presenting, I have these crazy thoughts coming into my head. And
I'm not the only one. I know there's others.
I'm sorry, guys.
I know there's others doing the same thing. But yes, I mean, you can be very creative with it. You could spell your name. You could figure out a way to actually direct it. But you'd have to know what, you know what? Actually, Amanda, this would be great for you to try, because you could learn a lot of physics this way. You could learn about the nature of forces and inertial forces and how they work. And you'll learn an awful lot for yourself by doing this as personal experience. So I think we should take up a collection and send you on the Vomit Comet.
No, but you know what? It's an experience you only have to learn once, and you'll never forget those lessons.
You know what? I had the opportunity to go on a submarine once decades ago, and I said it was the most fun I had getting seasick. Because it's a tube with end caps and it rolls on the surface. I got all sick. Went underwater, and it feels like how everybody feels now. It doesn't feel like you're moving. But it was the most fun I had. I think the Vomit Comet would be the most fun I had being really sick.
We've got about 35 seconds left.
I was just about to say, what a way to end the show. Oh, my God.
I know, and Tara got to ask only one question.
That's all right. It was a great answer.
It was a great set of answers, too.
Well, that's what I love about this topic. Like, one question can just lead to so many other possibilities, and this is why we get off course. I know I don't help, but that's the beauty of astronomy.
Fine. You're fine. We've got people out there, that are having a good time laughing and so forth. And just remember, the bottom line is, if you ever go on the Vomit Comet, maybe you'll have to wear a mask. Okay? So, yeah, there's our dog. That's Dingo. She wears her mask dutifully, and she did throughout the crisis.
And if you do go on the Vomit Comet or any other space-related thing, join our Facebook group and send the video. And send a warning. Warning before viewing.
Yeah, warning, 35 seconds in, Well, there you go, folks. Thank you for joining us on Sky Tour Radio, such as it sort of was. We hope you enjoyed some of the new things we're trying, and we look forward to hearing from you. And we'll be back next week, I believe, at the same time, same bat channel, as they used to say. I'm Batman. This is Mark D'Antonio, and we got Daryl down there. We have Amanda over there and Tara down there in the corner. And we all love you. Thank you so much for joining us tonight.
Bye, everyone.
We'll
Good
see
night,
you.
all.
Night.